So in this video we're going to talk about a prototype debugger for search strategies. Now, why might we want such a thing? Well, in the world of professional search, or any kind of search where the problem is more complex than just can be solved with simple keywords, we get what's called search strategies. And search strategies are complex collections of keywords, controlled vocabulary terms and Boolean operators, a little bit like what we're seeing on the screen here. And they can sometimes be articulated on a line-by-line basis, like this that we've got highlighted, or they can be articulated as one very long Boolean string. And in both cases, they're somewhat prone to error. They don't scale very well. They're quite difficult to look at and understand, and many studies have shown that there are often errors in these search strategies, which is obviously quite concerning because the whole evidence-based medicine community is based upon structured searching, and structured searching in turn is based upon Boolean strings and search strategies like this. So it's important that we get these things right. So what can we do to help make these search strategies more understandable and more reliable? Well, one thing that we can do is we can introduce tooling and ideas from the world of software engineering and software development environments that help us understand, visualize, and debug search strategies. So what we've got here is we've got that search strategy that we saw just a moment ago loaded into our prototype player. And what we can do with this player is that we can see our search strategy on the right and the canvas on the left, and the canvas will show a visual representation of this search strategy. So we can interrogate this search strategy here. We can click on the various range controls here to select various bits of the search strategy. So for example, we might say, well, we don't quite understand what's happening with these first few lines. So what we can do is we can select those first few lines and click play. And note that like a media player, it goes through step by step each line in this search strategy and builds it on the canvas, giving you a sense of what's actually happening in this search strategy. And at any point we can pick another area, or we can replay it, and we can pause and step through it step by step like this on demand. So that's what happens with the line by line ones. What happens if we want to have one that is in the form of a block, like we saw with this example here? Well, what we can do now is we can show you another example, and in this case there are no line numbers, but it's the same concept, that we've basically got the search strategy arranged on the right hand side and a visual canvas on the left, and we can let this thing play and we can interrogate various sections of it just like we did before. So let's scroll down and see this entire search strategy, and just as before with the line by line one, we can select a region and we can play that region. Now, because there are no line numbers, the animation is slightly different, but it's the same idea. It's stepping through it like a media player, showing you the focus on each line as it comes to it, and then building it up as a series of nested containers on the left. And incidentally, there are lots of different visualizations we could show on the left. We're just showing you one particular one here, but the real focus is what's happening on the right hand side. And you can see the focus here with the green lines showing which line we're looking at, and also the outside green lines, which show you the semantic scope of what we're working on. So that's the player, which helps give us insight into the structure and semantics of a search strategy. But what happens if a search strategy has errors in it? And it just so happens that this one here, and I challenge the viewer to see it, but there are actually errors in this search strategy, and the fact that they're quite hard to see in this form is exactly the point. But let's see if our debugger can find them. So we put them into our debugger, we enter the query string, hit confirm, and it builds. And sure enough, it identifies that there is a problem, and it says there's a syntax error, and it's highlighting the line, and we can see here that there is a missing quote. And this is a genuine example taken from one of the expert searching mailing lists where this is a genuine error. So we can rerun the parser now, and it goes past that line because that one's fixed, but it's found another error, and again this is a genuine error. There's an extra bracket, so we can remove that, run the parser again, and there's another error here. It's a semantic error. There is a line number is incorrect, so we can fix that. It looks like it should be 22, so we'll put it to 22. And now we rerun the parser, and sure enough it builds, but we can see that there's a little error message here on top right, showing that there's something wrong with the search strategy. So if we run our debugger, we switch to that tab, we'll see that there are 2 warnings detected, and there is a red highlight here on the canvas. So if we look at these warnings, and again this is borrowing ideas from software development environments, we can see that there's a pragmatic error here, that there's an unsupported field. This should be TIAB. I don't know if you can see, but it's actually TIEB. So we correct that. And then there's also incorrect line numbers. So we can click on that error and it takes us to the location of the incorrect line number. We can fix that. And there we go. Now the search strategy has built fully on the canvas and we've corrected all the errors. So that's it. That's our demo. That shows you how errors in search strategies can lead to complications in inefficiency and inaccuracy in evidence-based medicine. And we can use the techniques of visualization and ideas from software engineering to help us understand and debug those search strategies.